All right, it is 12:50 and I'm getting started. So last time we learned about the 5 exponent rules. There is rule number 1. It is called the product rule. The product rule. And what the product rule basically states is that you have a variable x and you also have a number, let's just call it m, and we are multiplying by x to the n power. So if that happens, we're actually adding the two numbers together. So I'm going to get x to the m plus n power. So that's the product rule. Okay, so I'm going to go ahead and talk about the quotient rule really quick. The quotient rule, that is going to be when we are dividing, actually. So here, I have the exact same setup. The only difference is I'm going to have x to the n power divided by x to the n power. And when that happens, we're not adding anymore like we're doing up here. We're doing subtraction. So I'm going to get x to the m minus n. All right, so that's the quotient rule. The quotient rule is only used when we are dividing. Okay, now let's talk about the power rule. Okay, so the power rule is when we take something to an exponent. So let's say I had x to the m power, and I'm actually taking that to an exponent n. M and n can be the same number, but they can also be different numbers, right? So if I have this kind of situation, I'm not going to be adding the exponents, but I'm not going to be subtracting either. I'm going to be multiplying. And that's how I get x to the m times n. Or I can write it without the dot. I could have x to the mn power. Okay? All right. I'm going to move on to the fourth rule. The fourth rule, it is called the negative exponent rule. All right, so for the negative exponent rule, we're going to have a negative exponent on top of a variable. So when we have a negative exponent, we're always going to treat this like a fraction. So a fraction has a top and a bottom, and sometimes we call these numerators and denominators. What I'm going to do is I'm going to make sure that 1 is always going to be the numerator. And then what I'm going to do is I'm going to change it to a positive n in the denominator. So I'm going to have x to the positive n. And that's how I do the negative exponent rule. Okay, so that's the negative exponent rule. And the fifth and final rule that we talked about on Tuesday was the zero exponent rule. The zero exponent rule. All right, for this one, we're going to have the same exact variable, x, but we're going to raise it to the 0 power. When you raise anything to the 0 power, you're going to get 1, but only if x is not equal to 0. Okay? That's an important thing to remember about that. Because if you have 0 to the 0 power, that is known as undefined, right? That's why you cannot let x be 0. So you could have 3 to the 0 power, you could have -2 to the 0 power, and you can even have 1 to the 0 power. But for all these, since you're raising it to the 0 power, you're always going to get 1. So these are all going to be 1s. But 0 to the 0 power, that is an undefined expression. Okay? So now what I want to do is, since we've covered the rules, I wanted to get into some two-step problems. And we're going to take a look at some of the two-step problems in just a minute. I'm going to make sure you guys can get this right here. So I'm going to wait just a minute and we'll get on to some of the problem sets that I posted. All right. So those are the 5 exponent rules: the product rule, the quotient rule, the power rule, the negative exponent rule, and the 0 exponent rule. So let's move on from this. Okay, so we are doing problem sets. And we are doing them from the part 2 or the 2-step problems. Okay, so for these problems, what I want to do is I want to work inside out. So what we're going to be doing is we're going to be working on the inside of the parentheses. And then after that, we're going to be using the power rule. Okay, so the first thing I do is I look on the inside of the parentheses and I try to use the big numbers first. So we're doing 25 divided by 5. That's just going to be 5, right? So the coefficients, those are the big numbers out in front. Those are going to be the ones to go first. Now, when I move on to my variables like this x right here or this y right here, we're going to be using the quotient rule. So I have a 10 on top and a 2 on the bottom. Notice we're subtracting. So if I have 10 minus 2, I'm going to get 8. So that's x to the 8. Over here, I've got this 6 and this 4. If I subtract those, that's 6 minus 4. That's going to give me 2. So now I basically got whatever I have in parentheses. And I'm raising everything to the 3rd power. So now I can actually cube everything on the inside. Okay, so there are 2 ways we can think about it. We can do the numbers first, and then we can do the variables second, or we could do the variables first and do the numbers second. This 5 out in front, when I do cube that, I'm going to get 125. And then I can start working on the variables. So I have an x inside there, and I have a y. Okay, so the exponents, we're going to be using the power rule, or rule number 3. So whatever number I have on the inside, I can multiply it by the number that's on the outside. So 8 times 3, that's going to give me that 24 that I want. And 2 times 3, that's going to give me that 6. And we're done. Okay, for the second problem, we're also going to go inside out first, because there's more things we can do on the inside of the parentheses than things we can do on the outside. Notice that my exponent is 2 on the outside, so at the very end, I'm going to square everything inside here. Okay? All right, so starting this off, we have 100 divided by 5. That's going to give me 20. And then I work with the variables x and the variable y. Here, I have negative 2 minus 3. that's going to give me a negative 5. And when I subtract these numbers over here, you get 3. So everything is still in parentheses and everything is still being squared. So now what I'm going to do is, since I have that 2 on the outside, I can square everything that's on the inside. Everything that's on the inside. Okay, so if I square the 20, you're going to get 20 times 20, right? That's going to give you 400. And now the exponents can be multiplied by what's on the outside. So negative 5 times 2, that's going to give me negative 10. I keep that a negative number. Then I work with the y. Here I have y to the 3rd power, but I'm squaring it, right? That's how I get that 3 times 2 is 6. And I can stop right there because there's nothing left to do. All right, so also notice this has a negative exponent. So if I really wanted to, I could write my answer like this, and it would be the exact same thing. So I'm still going to have 400 on top of the fraction. I'm still going to have y to the 6th power on the top. But what am I going to have on the bottom? It becomes a positive 10 on the bottom, right? That's that negative exponent rule coming back. So now notice I have a fraction now, and this expression is the exact same thing as this expression. So I could also write it like this, and I would still count that right. Okay, we're going to do one more like that. So this time I have 80 on top, and I have x to the negative 3 power, y to the 10th power, and z to the 11th. And then on the bottom, I'm going to have 16 x squared, y cubed, and z to the 0 power. So then when everything is done, I'm going to take everything to the negative 2 power and see what happens here. All right, so just like the last two problems, you want to do the inside out first. So I'm going to go on the inside. I'm going to do everything I can inside the parentheses right here. And then I'm going to take everything to the negative 2 power and see what happens. All right, so I got 80 divided by 16. That's going to give me 5. And then I move on to the variables. I'm going to use that quotient rule, which means we subtract the exponents, the top minus the bottom. So negative 3 minus 2, that's going to give me a negative 5. Then I move on over to the y's and I do those. 10 minus 3, that's going to give me 7. When I move over to the z's, I have 11 minus 0, that's just going to be 11. So now I've done everything on the inside. I put the parentheses around it, and I keep that negative 2 as the final exponent. What I want to do now is I want to raise everything to the negative 2 power. So this 5 out in front, that's going to be raised to the negative 2 power. These exponents, they can all be multiplied by negative 2 to get something. All right, so starting on the left side, I have 5 to the negative 2 power. I'm just going to take that outside of the parentheses. We can deal with that later once we figure out what it is. And then I multiply. So negative 5 times negative 2, that's going to give me a positive 10. If I look at the y variable, I got 7 times negative 2. That's going to give me negative 14. and over the z, you should get negative 22. So in this step, I'm taking everything to the negative 2 power. Okay? So now what I can do is I can figure out what 5 to the negative 2 power is. I can actually write that on the bottom as a positive exponent, right? Because if you've got these negative exponents right here, remember, I can always write those at the bottom of the fraction as a positive. And that's what we're actually going to be doing next. We're going to be using that negative exponent rule. So what does this look like? Well, the only thing that stays on top is going to be this positive 10. So x to the 10th power. Everything else has a negative exponent. So that's going to go in the bottom as a positive number. So I'm going to have 5 to the positive 2 power, y to the positive 14, and z to the positive 22. Now, I can't cancel out anything, right? Because to be able to cancel out something, I've got to have the same thing on the top and the bottom. And I don't have anything like that. The only thing I can do that's left is take 5 to the 2 power. And we know that's 5 squared, right? That's going to be 25. And I bring over my y and my z. So I can't do anything after that. That's how you know when you're done. All right, so go ahead and take a minute and get that down. We're going to move on to that last part of the problem set where we just use rules 1 through 3. All right, so these are the last ones we have to do. Okay, so each one of these problems is a different rule. We'll go through them one by one. For number 4, notice we have a division sign out in front. So we're going to be using the quotient rule for this one. All right, so we do the coefficients first, right? I've got a 25 divided by 5. That's going to give me 5. When you get to the variables, you're going to want to subtract. So I have 11 minus 7. That's going to give me my x to the 4th power. All right, so that's number 4. Number 5, notice we're taking everything to the 3rd power. That means we're going to be using the power rule. So I'm taking even exponents to exponents. And we know that's going to be rule 3, the power rule. So when I do this, I'm taking everything inside the parentheses and I'm cubing it. So 2 cubed, that's going to be 2 times 2 times 2. That's going to give me 8. So I know I'm going to have an 8 here. That's going to be that big number, the coefficient, right? The 8 can be multiplied by the 3 to get 24. So I'm going to have x to the 24th power. And this always happens when you have an exponent raised to an exponent. All right, for number 6, you have a dot in between. That means you're going to be using the product rule. So when I do the product rule, I want to make sure that I'm actually adding the exponents, not multiplying them. I'm going to reserve all my multiplying for the coefficients right here. And I'm going to underline those. All right, so 14 and 3, that's going to multiply to give me 42. And then the exponents, they're going to add up to give me 2, at least for the x. And for the y, I pretty much have a 1 right here, but I didn't write it here. So let me go ahead and do that. So 1 plus 9, that's going to give me that y to the 10th power. Okay, for number 7, notice I'm taking everything to the 4th power. So that's going to be the same thing as number 5, right? That's the power rule. So I'm going to be raising everything to the 4th power, even that 3 at the very front. So 3 to the 4th power, that's going to give me 3, 3, 3, 3. I've got 4 of them right here. So if I group the first 2 and I group the second 2, I can break it up into 9 times 9, which is 81. So that's going to be my coefficient, that 81. The exponents, they can be multiplied. So you're going to get x to the negative 8 power. Since it's a negative exponent, you can always write it as a positive in the denominator. So both of these are right. Okay, for the last 3, we're going to be using quotient rule. We're going to be using the negative exponent rule. And not only the negative exponent rule, but the 0 exponent rule. because everything here is being raised to the 0 power. All right, so for number 8, I've got 100 right here, and I've got a 5 out in front. We're going to actually be dividing these numbers. If I do that, I get 20. So that's going to be my new coefficient. The 20 goes out in front, and then I have to deal with whatever the x is. So here I've got a 12 and a -2. Notice that since I have a division sign right here, I've got to subtract the exponents. So 12 minus -2, that's going to give me a positive 14. So really what I'm doing is I'm subtracting a negative number. And we all know that's the same thing as adding a positive number, right? Minus minus equals positive. Okay. For the next one, we've got to write that as a positive number in the denominator. So I'm going to have 1 over y to the first power. I can write it like that, or since I know to keep the 1 on the top, the exponent 1 here is understood to be there. So I could also write it like this, and both of these would be the same answer. All right, so for the 0 exponent rule, remember that anything to the 0 power is going to be 1. That's always going to be the case for any problem that I give you. So everything inside here is being raised to the 0 power. So there's 2 ways I can think about it. The easy way is just to say anything to the 0 power is 1 and just be done with it. But notice I've also got the power rule going on. So I could also do it like this. I could take the 9 to the 0 power and then multiply the exponents, right? 4 times 0, that should give you 0. So really, I'm going to have 9 to the 0 power and x to the 0 power. And what is this and what is this? Well, they're both 1, so you're going to have 1 times 1. And that's 1 again, right? You could do it that way too. But do know that everything to the 0 power is going to be equal to 1. As long as it's not 0 to the 0 power, right? Because that's going to be undefined. Okay? So those are the 10 problems that I want to look at today.